Hello. In this video we're going to look at the idea of annuities and something called sinking funds. And for these I'm going to look at them a couple of different ways. First we're going to kind of get an idea as to how they work, and then we're going to look at a formula that can be used for them. It's a rather long and involved formula, but I'll show you how to use it and put it into your calculator. Then we'll look at a quicker and easier way using what's called the TVM Solver on your calculator. We'll just do a couple examples in this video. I'll put an additional video up that will show additional uses of the TVM Solver for your calculator in case you'd like to see additional examples. So let's go ahead and get started looking at annuities. Alrighty, so here is our notes, and I'm just going to start out with an example to see if we can develop the idea of what an annuity is. So suppose that you start by depositing $100 at the end of each month into an account that pays 12% yearly interest compounded monthly. How much money will be in the account after 6 months? So what I've done is I've assumed that you're starting in January, and we're going for 6 months: January, February, March, April, May, and June. And what I want to do is figure out what the total amount is. And the reason I'm doing this is to show you how sort of long and tedious it was if we were to do it by hand without using a formula. So what we'd have to do is since we're doing this depositing at the end of each month, we've got a deposit at the end of June that's just not going to do anything. There's no time for it to compound. So that June deposit at the very end of June is only going to be worth $100. However, the payment that we made in May is going to be able to accrue for a month. So what we're going to do is we're going to say, all right, I am going to start with $100, and then I'm going to accrue interest. So I'm going to do principal plus interest. And since I'm not looking at the compounding here, I'm just using it as simple interest. I'll get to the compounding thing later by coming up with a formula. I can just say I've got interest that's accumulating on $100 on an interest rate of 0.12, 12%, over a time period of just 1/12 of a year. And notice if we simplify this a little bit, 0.12 times 1/12 is going to come out to be 0.01. And then we've got 100 in each of these terms, so if I factor out 100, I'm going to get 1 plus 0.01, or 100 times 1.01. So my amount for May is going to be that I've got that $100, and it's accrued some interest, and when I multiply it by 1.01, I'm going to figure out how much interest that is. So now I go back to April, and for April, notice the only difference is I'm going to have 2 months that I'm dealing with this. Alrighty? And so I'm going to be accruing interest for 1 month here, and then doing it for another month back to April. So the quick and easy way to do that is to say that I've got $100, it's accruing interest, and it's compounding now for 2 months. Then for March, it's going to be the same thing, but for 3 months. For February, for 4 months. For January, it's accruing for 5 months. And then I would have to actually figure out what each of those numbers are, add them all up to get my total amount. And that's only if we're looking at 6 months. So notice that's going to get rather gross rather fast. If we were looking for, say, 2 or 3 years, we'd have to go through something like this. Or what we can do is we can use a formula. And the formula, let me just write it here, it looks like this. A, and that's going to be amount, just as before, only we're going to call this future value. We're just going to give it a different name, but it's the same thing we've looked at before. It's the amount at the end. Is equal to R, and here's a brand new a variable that we haven't used before, and the R is going to stand for payment. Why they used R, I don't know, because P was already taken. I don't know why they chose R, but they did. And that's going to be multiplied by, and I'm going to have brackets because this thing has got a lot of pieces and parts to it. The numerator is going to have 1 plus R over N raised to the NT minus 1 over, parentheses, R over N. And then I'm going to close my brackets. And all of these are the same as what we've looked at before. The little r is our interest rate. The little n is the number of compoundings per year. The t is the number of years. So if we want to do that for this particular example without having to go through all of this stuff, alrighty, we can do that. So what I'm going to do is I'm going to plug in what I know. I don't know the future value, but I do know what the payment is. I'm putting in $100 every month. Alrighty. And now I've got this parentheses with all this stuff in it. I've got 1 plus, my R is 12%, so I'm going to change that into a decimal point, 12, divided by my N, I'm doing monthly compounding, so that's going to be 12, raised to the N, which is 12, times my T, I'm looking at 12 months, which is 1/2 of a year, minus 1, all over R, which is 0.12, over N, which is 12 payments per year, or 12 compoundings per year. And there's my whole thing. So hold on real quick, let me grab my calculator. Okay, so I've got my calculator, and what I did while I was at it was I went back up above to where I had all of this stuff, okay, and I plugged that all into the calculator. I did 100 times 1.01 to the 5th plus 100 times 1.01 to the 4th plus blah, 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 and I got a total amount from up above of $615.20. All righty. Now what I'd like to see is if this thing is going to come out the same way, and it should. So let's see if we can work with that on the calculator. Now what I'd like to do, you can do this in pieces, but what I'd like to do is show you how to do the whole thing at once if possible. All right, and what we have to do is we have to be real careful with parentheses. So I'm going to write out right here how I would put it into the calculator. So I'd put in 100. Then I've got these brackets. So I'm going to use parentheses to show those brackets. Okay? So this is the bracket. And then I've got something in the numerator, so I'm going to put another set of parentheses for the numerator. Then within the numerator I have another set of parentheses, and within that I have 1 plus 0.12 divided by 12. And then I'm going to close that set of parentheses. Alrighty? Raised to the, I need parentheses around this exponent just like we've talked about previously. So I'm going to have 12 times 0.5, and I'm going to close that set of parentheses. Oh, I did that already. Okay, sorry about that. Okay, so I closed that set of parentheses for the exponent. Now I have minus 1, which is going to be the end of my numerator, so I can close the numerator parentheses. So here's the parentheses around this piece. Here's the parentheses around that piece. Here's the parentheses around the numerator. Divided by, I need parentheses around the denominator, 0.12 divided by 12. And then I need parentheses where my brackets were. So I'm going to close the brackets. All right, so if I plug all that into the calculator, let's see, I'm going to get 100 parentheses. Let's go to this so I have some room here so you can see better. 100 parenthesis, which is my bracket, parenthesis, which is my numerator, parenthesis, which is within my numerator, 1 plus 0.12 divided by 12, close parentheses, raised to the parentheses, 12 times 0.5, close parentheses, minus 1, close my numerator parentheses, divided by open denominator parentheses, 0.12 divided by 12, close denominator parentheses, close brackets, and notice I get the exact same thing that I got up above. So my answer is going to be, again, $615.20. Okay, so you can do it this way. Yuck. You could do it using the formula. Pretty much yuck. And notice you could simplify this formula if you wanted to. You could have 100. 1 plus 0.12 divided by 12. We did that up above. That was 1.01. And 12 times 1/2 would be to the 6th power, minus 1 over 0.12 divided by 12, which would be 0.01. So you could do that if you wanted to as well, and come out with the same answer. So I'll just show you that real quick. 100 parentheses 1.01 to the 6th minus 1, close parentheses, divided by 0.01, close parentheses, and we get the same thing. Okay? Now all those ways seem a little brutal. So what I want to do is show you another way using something called the TVM Solver on your calculator. Now in order to use the TVM Solver, I've got to know what the different pieces of the TVM Solver are. And what I've got is I've got some different variables in there. All right, and in order to find the TVM Solver on the calculator, what you're going to do is you're going to hit apps. Hopefully you've got an 83 or an 84. They come preloaded with this. If you hit apps, all right, this one, the only thing that came loaded on it was the finance, but you look for finance, and then you're going to choose the first one on that list, which is TVM Solver. And then you've got just a bunch of different things in here. You've got N, I%, PV, PMT, FV, P/Y, C/Y, PMT. Alrighty. So what I want to do is I want to talk through what each of those means. So the N is really our N times T, or we can think of it as total number of payment. Okay? Total number of payments. Our I% is our interest. And notice it says it wants it as a percent. So you don't have to change it into a decimal. PV stands for present value. And as we do more examples with these will feel more comfortable. PMT stands for payment. FV represents future value. P/Y is payments per year. C/Y is compoundings. Per year. And the last one, PMT, is when payment is made. And what we're going to typically do in this class is always make the payments at the end of the month, just like our example here said end of the month. So let's figure out what we have for the variables for this problem. Well, our N, our total number of payments, is 6, because we're dealing with 6 months. Alrighty. Our interest is 12%, so I just put in a 12. My present value, how much I'm starting with nothing. I'm making payments of $100, and since I'm making the payments, they're coming out of my pocket. The way it wants me to put that in is with a negative 100. All right, anytime the payments are going out of my pocket, those are negatives. My future value is what I don't know. That's how much I want to find. My payments per year are 12, since I'm dealing with monthly, and my compoundings are the same. Pretty much for all of our purposes in here, we're going to be using these as the same. And then the PMT down here is, we're going to choose end. So if I go to the graphing calculator and I put those things in, I have an N of 6, I have a I% of 12, my present value is 0, my payments are negative 100. Future value, I have something in there, but I don't care at this point. I'm going to come back and solve that. Alrighty. My payments per year is 12. My compoundings per year are 12, and it'll put that in for you. And this will be highlighted at end, and you want to leave it highlighted there. Now what I'm going to do is I'm going to move back up to future value. And if you look on your calculator, you'll see that you've got an alpha key. And typically it's green or a different color. And then on the enter key, the alpha that goes with that is solve. And that's what I want to do. I want to go up to the future value, which is what I want, and I'm going to hit alpha, enter, and what it's going to do is it's going to calculate what my value is. And notice I got 615.20. All right. 3 different ways to approach that problem. They all work. I think this personally is a little bit easier, but whatever works for you is fine. I've had people that like the formula in the past and use that, and that's fine with me. Okay, so let's go on to a sinking fund. And what I want to look here on the sinking fund is how much money would you have to deposit each month to have $12,000 in an account that pays 6% interest compounded monthly after 8 years. Alrighty, so I'm trying to put money away so that I'll have $12,000 in that account, and I can pull out some payments. All right, so I'm trying to find the payments on this one. Okay, before I was trying to find the future value. Now I'm trying to find the payment. So I could use my handy dandy formula from up here. So let's plug in everything that I know. I know the amount that I want at the end is $12,000. All right. I don't know the payment. I know the interest rate is 6%. I know that's monthly, so that'll be a 12. Raised to the NT, so that'll be 12 times, and I'm looking at 8 years. Minus 1, all over my interest rate, which is 0.06, divided by my N, which is 12. And I want to solve that for R. So notice what I could do is I could just say R is equal to $12,000 divided by that whole mess. 1 plus 0.06 over 12 raised to the 12 times 8 minus 1 all over 0.06 divided by 12. Alrighty, isn't that pretty? And then what I'm going to do is plug that whole thing into the calculator. And again, we just write how we would do that. We'd say 12,000 divided by, and now I need all these parentheses. I need a parenthesis around where this bracket goes. I need a parenthesis for the numerator, and I need a parenthesis for this first piece in the numerator. 1 plus 0.06 divided by 12, close that parenthesis, raised to the new parenthesis for the exponent there, 12 times 8, minus 1, close the parenthesis for the numerator, divided by new parenthesis for the denominator, 0.06 divided by 12, close the parenthesis for the denominator, and then close the parenthesis for the bracket. So if we plug all of that in, to the calculator. Let's see what that looks like. Out of here, I'd have 12,000 divided by parentheses, 1 plus 0.06 divided by 12, close parenthesis, raised to the parenthesis 12 times 8, close parenthesis, minus 1, close parenthesis, divided by parenthesis 0.06 divided by 12, close parenthesis, and I should be paying $97, and we'll round off to 70 cents. So my payment is about $97 and what did I say, 70 cents. Okay, and of course, as before, you could simplify this and go that direction. But let's see if we can do it using the TVM Solver. Again, what we need is we need N, we need I%, we need PV, we need PMT, we need FV, and then payment per year, C per year, and PMT. We know that down here that the payment, we always want that on end. Okay. The compounding is the payment per year. Since we're dealing with monthly, it's going to be 12. All right, now let's figure out what else we've got here. So for our capital N, we said that was the total number of payments. We said that was N times T. So since we're compounding this monthly for 12 years, this would be 12 times 8. 12 times 8 is 96. All right, our interest rate is 6%, so I can just plug in a 6. My present value, I'm starting with nothing. My payment is what I don't know. And my future value, I want to have $12,000 in there. All right, so now let's go to the calculator, plug all that into my TVM Solver. Okay, my N is, and you can plug it in this way. You can say 12 times 8 and then hit enter and it'll calculate it for you. My interest rate is 6%. My present value is 0. My payments I don't know. My future value, and so I don't care what's in there, is $12,000. My payments per year, compoundings per year are both 12, and it's at the end. Now I want to solve for my PMT, so I'm going to go up and highlight PMT. And I'm going to hit alpha, enter, and it tells me $97.70, and it's negative because it's coming out of my pocket. So that's the idea on annuities and sinking funds.